Okay, here's some guidance through this exercise. It's one of the hardest, in fact, the hardest we've encountered so far. So again, careful reading helps out. This is really important for giving you a dry run to the upcoming midterm, which is going to be turned in online. It's officially due after spring break, but if you want to turn in before then and enjoy the spring break, you can do that. So all that guidance is, and as well as the exam, is in La Lima. So here we go. Once you fill it in, the probability of each of these is as follows. That's just straight up from the reading, right? When you read all of this stuff. Okay, so let's start here with A. Don't worry about the 1/2. That's just the point allocation as well as these. But you should be getting full points for all of these since I'm pretty much doing it all for you anyway. It's the reasoning that matters rather than the answers. Remember, it's the same for the whole course. Show me your work, show me your reasoning. If you just give me answers, I can't give you much credit. Even if you get the answers wrong and you show me a lot of good work to get there, I can give you more credit. Okay, so the expected value is basically each of these branches, right? So either 1, you go there, it's okay, or 2, it goes to excess. The chances of that happening is 10%. And then there's an operator in the room and it goes there, or it goes here, and then this is the worst case scenario. Don't forget this right now. That's the addition coming later. So right now it just stops there, okay? So in a single operation, and I factor out here, you get, there's each unsuccessful, sorry, okay. So each unsuccessful operation costs the company $500, right? Uh, each successful operation gives them a profit of $500. So when does that occur? When do they have a successful operation? In this first branch, and then when they go here and there, right? So it'll be 500, you can say $500 times 0.9, plus the other option is 0.1 times 0.75 times 500. So that's all I did here. I took the 500 out and I put them together. 0.9 is one branch, or the other branch is 0.1 times 0.75. And then what happens in the worst scenario? You get damage of $20,000, and in addition, there's a $350 general expense for each operation. So whether you're successful or not, in this other case, you still have to minus off 350. So in the other case, you get 20,500 times the way the branch where it goes into excess and there's no operator. So 0.1 times 0.25. So it's 0.1 times 0.25. Do that calculation correctly, you should get minus 375, right? This is a basic type expected value calculation. You guys all should have been able to do this on your own without using my help. If you're not, then that means you're either not putting in the proper time or you're not doing enough reading and careful thinking. So check your understanding here by seeing whether or not you can do this on your own. Again, not relying on my video. If your company needs to make a profit of $50 to stay in business, should it continue? Obviously not. If it's a minus $375 operation, it's not going to make it. Company is now considering the installation of a 90% effective relief valve. So that's what I have here. 90% of the time, it'll automatically shut down. 10% of the time, not, right? So what is it going to be now? Well, this number right here, it's the same as before. You're still going to have these two branches, good or good. So that's 500 times this. So this whole chunk right here, that ends up being 487.5, which I have right here. I'm not going to calculate again. Minus, and now the negative one is this one. It goes right here, right? Okay? So there's the two sides here. Either you're safe or you're negative. So let's do the negative first. It's 20,500. Why 20,500? Well, it's 20,000 in damage to the equipment, and also $500 for each unsuccessful operation. So it's unsuccessful. So it's 20,500 times 0.1 times 0.25 times 0.1. So that's this branch right here, from there to there to there. That's what this represents, 0.1 times 0.25 times 0.1. This is the cost, right? That ends up being negative 51.25. Still minus 350, just like above here. And then the other branch I have to yet encounter is this one, right? It's not a successful operation. It's still unsuccessful, so you can't sell. You lose the 500, but you don't bust the machine, right? So it's minus 500 and then times 0.1 times 0.25 times 0.9, right? That ends up being this amount. When you calculate the overall amount, it's $75. Yeah, 75. So now the expected value is 75. If the cost of such a relief valve, or average over its lifetime, amounts to 20 per operation, would the company be able to make the profit it needs by installing the valve? Yes, because it's 75 minus 20, which is still $55 profit. What's the maximum cost per operation the company should be prepared to pay for the valve? Well, if it needs 20 bucks, I mean, if it wants to break even, right, then 25 is the most it needs that they can pay. Why? Not break, shouldn't break even. From B, if the company needs to make a profit of 50 to stay in business, that's its, not quite break even, but to stay in business, then 25 is the most it should be willing to pay, right? Because 25 minus 75 will be 50. That's the bare minimum it needs to stay in business. I'm going over this pretty quickly because I'm assuming you tried this in good faith, and I'm just sort of sketching the answers, and then you can go back and try it on your own. This is a really good exercise that will, again, hardest problem for the course so far, good preparation for the upcoming midterm 2. In this case, company G, suppose it would cost an additional $80 per operation to hire another operator, thereby ensuring that at least one operator sees the warning light 99% of the time. So instead of 90% of the time, you have 99 here and then 1% there, right? So this would be 500 times 0.9 plus 0.1 if it goes to excess. Sorry, it's still 90 here. And then the idea is it goes to excess 1, and then instead of this one being right here, 75, this one moves up to 99. So it'll be 0.1 times 99. So 0.1 goes to excess, but 99 because you're paying for now for 2 operators. This stuff is not the operator. This is steam pressure, okay. This stuff is the operator. Minus 20,500. And how does that happen? Well, it goes excess 1, 0.1, or 10% of the time. And then if they're out, that only happens 1% of the time, which is 0.01. You minus off the 350 for the general expense, and then the $80 for this new hire. That ends up equaling $49. So it sounds like a good idea, but when we do the overall calculation, $49, it's still, that's short of the 50 you need to stay in operation. So what you would choose if you have these 2 courses of action, either hire another operator or the valve, you choose the other one. Expected value rule is what gives you that.